Assalamu alaikum, good morning, namaste, sar sri akal, buenos dias. My name is Raja Salim Akhtar. Welcome in this new video. Recurrence relations. We can compute a new value with the previous value by using two-term recurrence relations. We compute the initial values the two-term recurrence relations are very useful for calculation of orthogonal polynomials recurrence relations for Legendre's polynomial of degree n are following. Number 1, npnx is equal to xpn dash x minus pn minus 1 dash x or pn minus 1 dash x dash for derivative equal to x pn dash x minus npnx. Number 2, pn plus 1 dash x equal to n plus 1 pnx plus x pn dash x, or it can be written as n plus 1 pnx equal to p n plus 1 dash x minus x p n dash x. You can remember anyone. 3 Pn dash x equal to x Pn minus 1 dash x plus nPn minus 1 x. Number 4 1 minus x square Pn dash x equal to n Pn minus 1 x minus xp nx, or it can be written as 1 minus x square Pn dash x equal to n Pn minus 1 x minus nx Pn of x, or x square minus 1 Pn dash x equal to n into x Pnx minus Pn minus 1 x. Number 5 1 minus x square Pn dash x equal to n plus 1 x Pnx minus Pn plus 1 x, or it can be written as 1 minus x square Pn dash x equal to n plus 1 x Pnx minus n plus 1 Pn plus 1 x. Or x square minus 1 Pn dash x equal to n plus 1 into Pn plus 1 x minus x Pnx. You can remember anyone. Three-term recurrence relations we shall study in the next video. Proof number 1. Method 1. By using the generating function, for to prove nPn x is equal to x Pn dash x minus Pn minus 1 dash x, we know that the generating function for Pn of x is 1 minus 2xu plus u square raised power minus 1 over 2, or it can be written as 1 over 1 minus 2xu plus u square under root, equal to sigma n from 0 to infinity Pn x un. This is a function of two variables u and x. So if we take the partial derivative with respect to u, then we keep x as constant, and when we take the partial derivative with respect to x, then we take u as constant. Now taking partial derivative, with respect to u on both sides, keeping x as constant, we get minus 1 over 2, 1 minus 2xu plus u square raised power minus 1 over 2 minus 1 will become minus 3 over 2 into minus 2x plus 2u equal to sigma n from 0 to infinity Pn of x nu n minus 1. This can be written as 2 cancel with 2, x minus u 1 minus 2xu plus u square raised power minus 1 over 2 minus 1. It can be written as minus xu plus u square equal to sigma n from 0 to infinity Pnx nu n minus 1. Equation number 1. Now taking partial derivative with respect to x, keeping u as constant on both sides, we get minus 1 over 2, 1 minus 2 ux plus u square raised power minus 3 over 2 minus 2u equal to sigma n from 0 to infinity Pn dash x un, or it can be written as u into 1 minus 2xu plus u square raised power minus 1 over 2 over 1 minus 2xu plus u square equal to sigma n from 0 to infinity Pn dash x un. Equation number 2. Now dividing equation 1 by equation 2, we get x minus u over u equal to sigma n from 0 to infinity Pn x nu n minus 1 over sigma n from 0 to infinity Pn dash x un. This term will be cancelled. Only the remaining terms shall be this. Or it can be written as by cross multiplication u sigma n from 0 to infinity Pn x nu n minus 1 equal to x minus u sigma n from 0 to infinity Pn dash x un. Only simplification. This can be written as sigma n from 0 to infinity Pn x n un. This is equal to sigma n from 0 to infinity x Pn dash x un minus sigma n from 0 to infinity Pn dash x un plus 1. Comparing the coefficients, or equating the coefficients of un from both sides, we get on this side, this can be written as n Pn x equal to, this term will be x Pn dash x minus, this term can be written as Pn minus 1 dash x. Note it and remember it can also be written as r Pn minus 1 dash x equal to x Pn dash x minus nPn of x as required. As required. Remember, method 2, this from 3 term recurrence relations, usage, proof of the 3 term recurrence relation, you shall study in the next video. we know that 3-term recurrence relations as Pnx is equal to Pn plus 1 dash x minus 2x Pn dash x plus Pn minus 1 dash x. Equation number 1. Remember this one as a formula, and another 2n plus 1 Pnx equal to Pn plus 1 dash x minus Pn minus 1 dash x. Equation number 2. Now only subtracting 2 from 1 we get the required result. Now subtracting equation 2 from equation 1 we get note this 2Pn minus 1 dash x equal to minus 2n, only subtracting Pnx 2x Pn dash x. It can be written as dividing by 2 or Pn minus 1 dash x equal to minus n Pnx plus 6 Pn dash x, or it can be written as n Pn x equal to x Pn dash x minus P n Pn x as required. This is also very easy. In the exam you can write anyone. This is very easy and smallest. Only you remember these two formulas, subtract and finish. Now we prove the second recurrence relation. Pn plus 1 dash x equal to n plus 1 Pn x plus xp n dash x. Remember, or it can be written as n plus 1 Pnx equal to Pn plus 1 dash x minus x Pn dash x. Remember, proof we know that 3-term recurrence relations are Pn of x is equal to Pn plus 1 dash x minus 2x Pn dash x plus Pn n minus 1 dash x and second is 2n plus 1 Pn x equal to P n plus 1 dash x minus P n minus 1 dash x. 1 and 2. Therefore, adding equation 1 and equation 2, we get 2n plus 1 plus 1 Pn of x equal to, very easy, 2 Pn plus 1 dash x minus 2x Pn dash x. This implies 2 will be cancelled throughout, n plus 1 Pn x equal to Pn plus 1 dash x minus x Pn dash x. As required R, it can be written as Pn plus 1 dash x equal to n plus 1 Pn x plus x Pn dash x. Hence the proof is complete. Number 3, Pn dash x equal to x Pn minus 1 dash x plus n Pn minus 1 of x. Remember, proof we know that the recurrence relation Pn plus 1 dash x equal to n plus 1 Pn x plus x Pn dash x. Number 2, which use here to derive next. Now replacing n by n minus 1, we get this will become Pn dash x equal to n minus 1 plus 1 cancel, and there will be only n Pn minus 1 x plus x Pn minus 1 dash x, or it can be written as Pn dash x equal to x Pn minus 1 dash x plus n Pn minus 1 of x. Very, very easy proof. Number 4. Number 4. This is 1 minus x square Pn dash x equal to n Pn minus 1 x minus x Pn x, or it can be written as 1 minus x square Pn dash x equal to n Pn minus 1 of x minus nx, only multiply n inside, Pn of x, or it can be written as x square minus 1, interchanging, taking negative common both sides. X square minus 1 Pn dash x equal to n x Pn x minus Pn minus 1 of x. Proof. We know that the recurrence relations now we use the following these two. One is nPn of x equal to xPn dash x minus Pn minus 1 dash x, and Pn dash x equal to xP n minus 1 dash x plus n Pn minus 1 of x. This can be written as xp n dash x minus Pn minus 1 dash x equal to nPn of x 1, and this side Pn dash x minus x Pn minus 1 dash x is equal to nPn minus 1 of x. Equation 2. Now multiplying equation 1 by x and then subtracting from equation 2, we get x square Pn dash x minus Pn dash x, very easy step, note it, nx Pn of x minus nP n minus 1 x. This can be written as x square minus 1 Pn dash x equal to, taking n common, x Pn x minus Pn minus 1 of x. Or it can be written as 1 minus x square Pn dash x equal to n Pn minus 1x minus x, only interchange the terms. Or it can be written as 1 minus x square Pn dash x equal to nPn minus 1x minus nx Pn of x as required. Number 5. This is also very easy. 1 minus x square Pn dash x equal to n plus 1 into x Pnx minus Pn plus 1 of x, or it can be written as 1 minus x square Pn dash x equal to multiply inside n plus 1 x Pn of x minus n plus 1 Pn plus 1 of x, or it can be written as x square minus 1 Pn dash x equal to n plus 1 into Pn plus 1 of x minus x Pn of x. Remember, proof also very easy. We know that the recurrence relations one minus x square Pn dash x equal to n into Pn minus 1x minus x Pnx and Pn plus 1 dash x equal to n plus 1 Pnx plus x Pn dash x. In the first formula replace n by n plus 1. We have 1 minus x square Pn plus 1 dash x equal to n plus 1 into, it will become Pnx minus x Pn plus 1 of x. Equation number 1, and this is equation number 2. Now using equation 2 in 1, we get Pn plus 1 dash x, this value put here, 1 minus x square into n plus 1 Pn of x plus x Pn dash x equal to n plus 1 into Pn of x minus x Pn plus 1 of x. Multiplying n plus 1 Pn of x minus x square n plus 1 Pn of x plus x into 1 minus x square Pn dash x equal to n plus 1 Pn of x minus x n plus 1 Pn plus 1 of x. Cancelling the term, this term will cancel with this, and this term can be written as here as x is not equal to 0, as x not equal to 0. So dividing both sides by x, both sides by x, we get minus x n plus 1 Pn of x plus 1 minus x square Pn dash x equal to minus n plus 1 Pn plus 1 of x, or it can be written as 1 minus x square Pn dash x equal to x n plus 1 Pn of x minus n plus 1 Pn plus 1 of x, or it can be written as in other forms or 1 minus x square Pn dash x equal to n plus 1 common into x Pn of x minus Pn plus 1 of x, or in this form x square minus 1 Pn dash x equal to n plus 1 into Pn plus 1 x minus x Pn of x as required.